Okay, so today we learned how to solve using factoring. And remember that solving is allowing us to get the solutions or the zeros to a quadratic function. So remember, each of these equations is a quadratic that makes a U-shaped graph. And the U-shaped graph has two places where it hits the x-intercept, or it could have one or it could have none. And so when we say solve using factoring, we want you to factor so that you can find the x-intercepts or the places where this U-shaped graph or this parabola hits the x-axis. So on Friday we learned how to factor, and in order to factor this, we're looking for two factors that multiply to give us negative 10 and add up to a positive 3, which would be a negative 2 and a positive 5. That gives you negative 10, and then negative 2 plus 5 gives us a positive 3. So our two factors are going to be x minus 2 times x plus 5 equals 0. Now, at this point, we have to set each factor equal to 0, and then we have to solve for x. So we would add 2 to both sides, and you would get that x is equal to 2. Subtract 5 from both sides, and you would get that x is equal to negative 5. So our two factors are positive 2 and negative 5. And you will notice that they're the opposite of what you see inside the parentheses. So that's kind of a little shortcut on how we can go from the parentheses to our solutions. Okay, for number 2, two factors of 40 that add, or negative 40 that add up to positive 6. We've got 10 and 4, so x plus 10 and x minus 4. 10 times negative 4 is negative 40, and 10 minus 4 is 6. So our two factors are going to be x equals negative 10 and x equals positive 4. And again, I skipped this step on setting them each equal to 0 like I did in problem number 1. Just went straight to the answer. But what you are doing is x plus 10 equals 0 and x minus 4 equals 0, and you're solving for x. On the next one, we're looking for two factors of 6 that add up to negative 5. So you would think it's 6 and 1, but it's not. We're looking for two negatives. So this is x minus 3 and x minus 2, because negative 3 times negative 2 is positive 6, and negative 3 plus negative 2 is negative 5. Okay, so our solutions are x equals 3 and x equals 2. And again, I skipped the step of putting each parentheses equal to 0. On number 4, we're looking for two factors of negative 30 that add up to negative 7. It's going to be x minus 10 and x plus 3. Negative 10 times 3 is negative 30, and negative 10 plus 3 is negative 7. So to get the solution to each one of these, x is equal to 10, and x is equal to negative 3. In number 5, we have to factor using the greatest common factor, because there's only two terms. So x is what they have in common. So if I factor out an x, x times x gives me x squared, and x times 7 gives me x times negative 7 gives me negative 7x. So this is how I would factor this one. It would become x times x minus 7. That's pretty much the distributive property backwards. And now we would set each individual term equal to 0. So x, which is the first term outside the parentheses, is equal to 0. And then x minus 7 is equal to 0. So here's one of my answers, and then my other answer is going to be a positive 7. On this one, this is a difference of two squares, or dots as I like to call it. And so we're looking for x that's being squared, and we're looking for 6 that's being squared. So our two factors are x plus 6 and x minus 6 are equal to 0. So my two solutions are going to be x equals negative 6 and x equals positive 6. Keep in mind that there's a difference between the factors, that's what these are, and the solutions, which are your actual zeros. Okay, Those are factors. These are solutions in all of the problems we just did. All right, number 7 is a word problem. So it says a rectangular garden measures 24 feet by 10 feet. So here's your rectangular garden, 24 by 10. By adding x feet to the width and x feet to the length, the area is doubled, okay? So what is the area right now in this rectangle is 240. So the new area of our new rectangle is going to be doubled, which would be 480. And that's if we add x, so add x to the length and add x to the width. And the area will be doubled, so 2 times 240 is 480. Now, it asks to write an equation for the garden's area, okay, so the new garden. So our equation is going to be x plus 24, I just turned that around, times x plus 10, again, just turned it around, and length times width is equal to area, which in this case is 480 feet. Okay, the next one is to write it in standard form. So we need to multiply these two and try to get it equal to 0 so that we can write it in standard form. So when I multiply x plus 24 times x plus 10, I get x squared, 10x, 24x, and 240. So I end up getting x squared plus 34x plus 240. Okay, and then that is equal to, I should write this over here. Take this off, give myself some room. That's equal to 480. So let's do the box over here. Okay, so now if I need to set this equal to 0 to get it in standard form, I am going to subtract 480 from both sides. So I'm going to end up having x squared plus 34x minus 240 is equal to 0. Okay? And then it asks for you to solve for x. So we have this standard form quadratic. And we're going to solve for x, which is our solutions, like what we were doing in 1 through 6. But we're going to do that with this particular equation using factoring. So I'm looking for basically 2 factors of negative 240 that add up to 34. So we're going to have, let's see, 24 and 10, right? Because 24 times 10 is 240, so negative no, let's think. It's not going to be 2 and 24 and 10. It's going to be I think a 240. That's going to be 40. One's going to be negative and one's going to be positive, and it's got to be a bigger number here. So let's think, 240. You don't know what the factors are, you start making your factor tree. So 24 times 10 is what the obvious one is, but there's no way that 24 and 10 can give me 34 unless they're both positive or both negative, and that doesn't give me what I need, because I need negative 240. So we've got to start thinking of other factors of 240. So how about 6 and 40? Ooh, there we go. 6 times 4 is 24 with a 0. Good. So 6 times 40 is what we're going to have. So this is going to be a positive 40 and a negative 6. Because that will give me negative 240 when I multiply it, and then 40 minus 6 is 34. Okay, so my 2 solutions are going to be 6 and negative 40. Okay? Now, if my x value were negative 40, and I went back and I was talking about a length or a width of a rectangle, is that possible? That is not. So we are going to throw the negative 40 out, and 6 is going to be our x value. So x is going to be equal to 6. Now that is not our length, that is not our width, that is what x is. So the question for D says, what are the new dimensions of the garden? Well, remember, if you go back to the original, we had that the dimensions were 24 plus x and 10 plus x. So if we go back and substitute in a 6, 24 plus 6 gives me a width of 30, and 10 plus 6, I can get through all this mess, gives me a length of 16. So a 30 by 16 would be the new garden. And so then the perimeter of the new garden, if we have a 30 by 16, that is going to be 30 plus 30 plus 16 plus 16, which should be 92. Okay? It's a lot of work for that problem, but you definitely need to know how to do one of these.